Hi students, welcome to our physics channel, Physics and Me. Today I'm going to explain the continuation of waves topic. It's a third video, third lecture on waves. So in the second video, we have discussed about what is meant by a wave function. In that, especially we have seen instead of a wave, we have seen a pulse which is a traveling. Am I right? Now, the same pulse. I have already told you the pulse equation. The pulse equation. It's a general equation of pulse. And I already told you, do you remember that? That is y is equal to a by b plus x minus or x plus r minus vt whole square. Okay, this is a general equation of a pulse. And we have already seen one example and we have drawn a pulse regarding this equation. We have drawn the graph also. In that we have got the form of a pulse like this. Okay, see, if we take a graph between y and x, then definitely with this equation we will get a pulse. Okay, now in this, how can we say that a wave is or a pulse is going towards right or towards left with what velocity? How can we say that? I will tell you a small example. I'll tell you a small example problem. It is y is equal to, a pulse equation is given as y is equal to, okay, 10 by 5 plus x plus 2t whole square. 10 by 5 plus x plus 2t whole square. Okay, now we have taken such pulse equation. This is a general form, and which is a, here y is a function of x and t now. Understand? Now what we have to do here, we should understand in which direction is a pulse going. If we write this function y of x comma t, which is equal to 10 by 5 plus x plus 2t whole square, then we should say what is the direction of propagation of pulse here. Okay, now what is the direction of propagation of pulse? Means in which direction it is moving, whether it is going in positive x direction or it is going in negative x direction. That we have to understand. See, when we give a jerk to it, this is a function regarding that. Now, what is the amplitude of it? First of all, let us discuss the amplitude here. First, amplitude of the above equation, as already I have told you in the previous class, amplitude of the above equation, A can be written as what? A by B, direct formula. Why? Because if you want to get the maximum value of that equation, then definitely x plus 2t has to be 0. Am I right? Therefore, we can write here it as 10 by 5, which is equal to, if that is given in centimeters, then obviously it is in centimeters, right? And what is the velocity of that pulse? Already it is given that, see, x plus, instead of v, we have taken 2 here. Okay, but x plus vt we are taking. Now we need to find out in which direction it is going. Okay, now what is the direction of motion? See, how can we say that? See, for example, at time t is equal to 0, initially the pulse is started from where? Okay, now what is the initial position of that pulse? Then we can write it as y of x is equal to, or y of x comma 0 is equal to, y of x comma 0 is equal to 10 by 5 plus, okay, what is x here? X plus x plus 0 whole square, no, x plus 0 whole square. Why? Because 2 into 0, it is 0. So x plus 0 whole square, it is written as x square. This is y of x comma 0. Then again, where will it be maximum? Here, suppose if this function is maximum, at what value? At x is equal to 0, then definitely it will be maximum. See such ones. At x is equal to 0, which means that at the origin, can we say that it is at the origin? So at x is equal to 0, then y can be written as 10 by 5, which is equal to 2 centimeter, which is nothing but maximum value of it. Yes or no? Nothing but its maximum value. It is maximum value, right? Okay, now again, the y value, the value of y will be maximum at some other place. Where is that? Again, it will be maximum at x plus vt distance. Am I right or not? So if we want to find the next value where it will be maximum, then what we have to do? Suppose it has gone to certain distance. After 1 second, we are calculating. Okay. After 1 second, the pulse has gone to some distance. Okay, now with certain velocity. Then we have to take it as at time t, or at time t is equal to 1 second. After 1 second, we are calculating where is that part, where is that pulse. Okay, now then what we have to do? Then we can write it as y of x comma 1. Y of x comma 1. That t is equal to 1 second, as I have already told you, no? Is equal to, we can write it as 10 by 5 plus x plus, instead of 2t, here if we substitute t is equal to 1, then you will get x plus 2 only, no? So x plus 2 whole square. Understand? We have got another equation at t is equal to 1 second. Okay. Now in this, if we want to get, observe that carefully, observe that equation carefully. If we want to get again the maximum value of y, in this, again, if we want to get the maximum value of y, then what we have to do? It's quite simple. See here, if we put at x is equal to minus 2, then definitely x plus 2 has to be 0. Then only you'll get the maximum value of y. Whatever the value you may substitute instead of x, then y value should not be, y value will not be maximum, except it is minus 2. Now, am I right or not? So x value is minus 2 centimeters. Now let us consider that in centimeters, no problem, right? So x is equal to, at x is equal to minus 2 centimeters, then y will be again maximum. Y will be again maximum. That is again 2 centimeters. Again maximum. See, after what distance? After x plus 2t distance. X plus 2 distance. Am I right or not? X plus 2 distance. Means after minus 2 centimeter. Minus 2 centimeter means, is it along positive x direction or negative x direction? It is obviously along negative x direction. Am I right or not? Means if we consider that, see, for example, see, this is a pulse. First, initially, the wave y value will be maximum at 0, he said. Am I right or not? So how to draw that? Y value will be maximum at 0 means how to draw that? Like this we have to draw. Why? Because at x is equal to 0, at the origin, at x is equal to 0 means y will be maximum. Here y is maximum. Do you understand? Y is maximum. How much will be its value? That is 2 centimeter. Then after what distance, again we are getting minus 2. I'm sorry. After what we are getting, for what distance we are getting again y value is 2 here. After x plus, I mean after minus 2 centimeter means in x direction only. In x direction only at minus 2 centimeter, again you will get a maximum value. Again you will get a maximum value at minus 2 centimeter. Do you understand? See here, so that's why what we have to take in this, we have to consider it as what is a velocity of it. Yes or no? What is the direction of velocity or what is the magnitude of velocity? Obviously, we can say that time interval is 1 second only, 0 to 1 second means time interval is 1. Then what is the displacement traveled? Then velocity can be written as minus x by t. So we can write it as or minus delta x by t, change in position, right? So minus 2 by 1, we can write it as minus 2 centimeter per second. This is a speed of wave or this is a velocity of a pulse. What does it mean? It means that why here we have got negative. That's why we can say that the pulse is traveling. The pulse is traveling along negative x direction. Okay, now. So from this, what have we understood? If we are writing the function as y of x minus vt, if we are writing the function as y of x minus vt, okay, now from this we can easily say, no, if we are writing the function as x minus vt, then it means that the pulse is going towards positive x-axis, right? And if the same thing, if we write it as x plus vt, y of x plus vt, then we can understand that. See here it is x plus vt. That's why we can understand that the pulse is going towards left. The pulse is going towards left with what velocity? With 2 centimeter per second velocity. Okay. Now. So this is a basic thing about waves. Means in that waves we are explaining. First of all, we are discussing about the pulse equation. This is a general form of pulse equation. Again, I'm saying this is a general form of pulse equation. And what is a amplitude of it? How to find the amplitude in this equation? Then we can write it as y is amplitude of this total is equal to a by b. If you want to get the amplitude, then we have to take x plus vt or x minus vt should be equal to 0. Then only we can get the amplitude. Understand? So that is about pulse equation. Okay. Now just observe that carefully. Whatever I did. See here. First, if you want to find the amplitude, then it is 2 centimeter. Maximum value of y. At time t is equal to 0, I have calculated. And at time t is equal to 1, I have calculated maximum values. Later, if we take the velocity, then we will get velocity as minus 2. If we are getting velocity as minus 2, it means that it is going towards negative x direction. Yes or no? Right. Now, let us go somewhat forward. Okay. That is, now I'm going to explain you what happens if we generate continuous pulses. If we generate continuous pulses, if we take a rope, okay, then first time taking the rope, this is a rope. Now, for the first time, if we just give a jerk to it, up and down, just up and down, then one pulse will be generated and it will go as it is. Whatever we have seen until now, the same thing. Okay, now only up and down and again coming to the same position. So that one pulse will be generated. Now, if we generate, okay, now once up and down and again from here to here, means like this. If we are generating a wave like this, if we are disturbing, if we are creating a disturbance like this, see, let us understand this is a mean position. Now going up and coming down and again coming to the same position, then it means that we can create one wave in it. We can create one wave. So if we give a jerk to it like this, then one wave will be created continuously. Okay, now one wave will be created and that wave will go. Okay, now see, if we do the same process continuously, then what happens? Waves will be generated and those waves will be propagated along rope. What do we call that rope? See here, if the amplitude of that wave is constant, if that amplitude of wave is constant, which means that there is no attenuation, okay, now, then we can say that it is called as a plane progressive wave. As long as the wave is passing through the rope, if there is no difference or if there is no dissipation of amplitude, if there is no decrement of amplitude, means continuously with the same amplitude, the wave has to propagate. Then if it propagates like that, then we have to call it as a plane progressive wave. Okay, now. So now let us understand about plane progressive wave. Plane progressive wave. What is a plane progressive wave? Just now I said plane progressive wave means once if the wave is generated, suppose if the wave, if the wave is propagated, if the wave is propagated, okay, with constant amplitude, with constant, if the wave is propagated with constant amplitude, okay, without any change in amplitude or without any attenuation, then we can say that then that that wave is called as, that wave is called plane progressive wave. Plane progressive wave. That wave is called as plane progressive wave. See, this is about a plane progressive wave, which means that, see here, once if one wave is created like this, see here, I'm drawing x and y axis first. I'm drawing x and y axis. Okay. Now, if we understand that the wave is started from the origin, means it is originated from O. Okay. Once the wave is originated like this, then there will be a continuous traveling of wave without the change, without decrement of amplitude or increment of amplitude, means by taking amplitude as constant, okay, now let us understand that, suppose if we consider the oscillation of particles here, if we consider the oscillation of particles here, understand, see how the particles will oscillate while the wave is propagated like this, the particles in that will be oscillated up and down, yes or no? Okay, here if the particle is there, then it will oscillate up. Here if the particle is there, it will oscillate up. Then what do we call this distance? That is called as amplitude, maximum displacement, right? And here up, and here down, here down, all the particles in this, they oscillate downwards, they oscillate downwards. And again the particles here, they oscillate upwards, understand? And again after this one, they oscillate downwards, particles are oscillating downwards. Do you understand? See, this is how the wave is being generated. How the wave is being generated. Okay. Now, if the wave is being generated, let us assume that a particle is at this position. Let us assume that the particle is at this position. Now, again, it is reaching to the maximum value. It is reaching to the maximum value. This is again maximum value, amplitude. Okay. Here, this is a maximum value. And here, this is a maximum value. Okay, now assume that second time here, when it gets the maximum value, then let us assume that it is at a certain position x from the origin. It is at a certain position x from the origin. It is at a certain position x from the origin. Understand? Certain distance x from the origin. Now, before what distance before what distance it was again having the same value of y, same y value. See here, the y value here it is maximum, which is nothing but here y is equal to a. Not only this position, any position you may take. Okay, now again the same type of position of the particle will be before what distance the same position of the particle will be. Okay, will be there. Okay, now so first position now I'm taking it as x first. First position I'm taking from the origin as x now. Now assume that this wave is traveling with a velocity v here. Assume that the wave is traveling with a velocity here. So see here, this was the initial position, and assume that the wave is propagating with a velocity v. This is the velocity of wave. Okay. Now see here, from the first position to the next position, what will be the distance? If you want to find that, the distance between two successive positions, the distance between two successive positions can be written as, it can be written as, the distance between these two successive positions can be written as here speed into time, velocity into time. Am I right? Therefore, see here, the displacement now can be written as what was the uh, displacement at which we have got again the same value of y, same value of y. Okay, now again suppose at x distance we have got maximum value. Okay, now, and before that, at what position the maximum value was there? The maximum value of y was there, or the same position was there at a distance x minus vt. Yes or no? At a distance x minus vt from the origin. See here, if we calculate like this, see here, if we take the distance from the origin, then we can write it as at x minus vt position, at x minus vt position. Okay, now whatever the y value is there at x distance, then the same y value we will get at x minus vt distance. The same y value we will get at x minus vt distance. Okay, whatever it may be. Now let us consider that actually if you want to write the equation of this wave motion, general equation of wave motion, or expression of this wave, we can write it as y is equal to a sine ax. A sine ax. How can you write it? It is nothing but it is similar to the graph between sine theta and theta. In mathematics, it is very similar to that of the graph versus sine theta graph, sine theta versus theta graph, same thing. So in that, in y direction, if we consider sine theta, and if along x direction we consider theta, then the same type of graph will be formed. Even here also, that's why along y direction we are taking y here. Y is our displacement of the particle along y direction, which is equal to a sine ax. Okay, now a sine ax, similar equation, right? Now in this equation, at see here, how do we write it actually? Y of x comma t, this displacement can be explained. This displacement can be explained in terms of both x and t. It is a function of both x and t. Means after some time, after t time, okay, now where is the position of the particle? Where is the particle? After some time, where is a wave and where is a particle? If you want to find out the wave, then we have to write it as x. At what distance you have to calculate, and what is at that x distance, what is the position of the particle? At x distance, what is the position of the particle? Okay, now suppose if that position is somewhat at this, if that position is this one, okay, now, so some at some position the particle was there. At which distance? At x distance from the origin. The position of the particle is y. At what time? At t time, at the time t. Okay, now so therefore y of x comma t, clearly it can be written as, So at x is equal to 0 now, see here, at x is equal to 0 now, okay, y of x comma 0, then we can write it as a sine ax. This is clear. At y of x comma 0 can be written as a sine ax at t is equal to 0 seconds. Okay, now what is the actual position at 0 seconds? In this diagram only it is there. No, at 0 seconds there is no y value also. Y value is also 0. Am I right or not? So at t is equal to 0 seconds, y value is 0 and x value is also 0. So if x is 0, if x is 0, here we can say that y is also 0. Why? Because if we just substitute instead of x, if we substitute 0, then we will get sine 0 is obviously 0, right? Then after what distance again we will get y value as 0? After what distance we will get y value as 0? Observe here in this diagram. After what distance again we will get y value as 0? After, okay, lambda by 2 distance. Yes or no? Why? Because I already told you what is lambda, wavelength. Okay, now at half of the wavelength means at lambda by 2 distance, again we are getting y value as 0. So we can write it as at x is equal to lambda by 2. At x is equal to lambda by 2 distance, again we will get y is equal to 0. Yes or no? From the diagram, we are observing that, okay? From the diagram. Now, if y value is 0 at x is equal to lambda by 2, what does it mean? It means that a sine a into lambda by 2, a sine a into lambda by 2 is equal to what? 0. Send this here to that side so that it will become 0 again. And sine a into lambda by 2 is equal to 0. What we have to understand from this, okay? Now, 0 means again, after what phase we are getting 0 here? What is a phase here? After pi radians. Am I right or not? So, sine 180 is nothing but 0, right? So, therefore, we can write a lambda by 2 is equal to pi. After pi radians, we are getting 0. That's why we are writing it as a lambda by 2 is equal to pi, right? Therefore, we can write A can be written as, now we have got A value. What is A now? A can be taken as 2 pi by lambda. This is A value. Now substitute that A value in the given equation. What is the given equation? Y is equal to A sine A into, sorry, A sine. What is the value of A now? We have to substitute it as 2 pi by lambda into x. 2 pi by lambda into x only, no? A sine 2 pi by lambda into x. This is a general form of equation now. Now we have got A value. Okay, now. Now let us consider that again, this is y position actually, whether it may be maximum or it may be anything, any position. Again, the same position can be achieved at what distance? Again, the same position can be achieved at x minus vt distance. Am I right or not? Therefore, again we will get y of, okay, now again we will get the same value of y at what distance? A sine 2 pi by lambda into x minus vt distance. X minus vt distance, as we have done already, or we have understood how x minus vt distance we will get the same value of y. We have done previously also by taking pulse. Even here also in this example also I have taken. Okay, now so 2 pi by lambda into x minus vt. Okay, now this is y. Now we can write it as y is equal to a sine 2 pi by lambda into x minus 2 pi by lambda into, how can we write this v value? V can be written as wavelength by time taken, okay, into t. Okay, na? Now see here lambda lambda gets cancelled. Therefore, y can be written as a sine 2 pi by lambda into x minus 2 pi by t into t. This is a general equation of a plane progressive wave that we have got until now. Okay, now what is a general equation? Observe that y is equal to a sine 2 pi by lambda into x minus 2 pi by t into t, small t. Understand? This is a general equation of a plane progressive wave. Okay, this is a general equation of a plane progressive wave. What is that? Y is equal to a sine 2 pi by lambda into x minus 2 pi by capital T into small t. This is the general equation. Okay. Now in this, if we observe that equation carefully, once again, if we observe that equation carefully, then we can write it as, now I'm going to write this wave equation as y is equal to a sine what is 2 pi by lambda? 2 pi by lambda, I'm taking that value as a constant k here, k into x minus 2 pi by t is nothing but omega, right? So omega into t. Okay, now y is equal to a sine kx minus omega t. This is a general equation. Suppose here we have taken that the wave is started from origin. Means wave is originated actually, right? It is started from the origin, whatever we have taken in this diagram. Suppose if this wave is not starting from the origin, the wave has already started from some other point. How can we write that equation? If it is started from the origin, then we can say that the initial phase is zero. Initial phase is zero. Okay, now, and if it is not started from the origin, for example, if we consider that if we consider that here the wave is already, see here, if the wave is started like this, if the wave is started like this, it's not started from the origin, then how do we write this phase here, phase relation? What is the initial phase to be written here? Then we can write this equation as y is equal to a sine kx minus omega t x a sine kx minus omega t plus phi, here we have to write plus phi. And suppose if the same wave is started like this, if the same wave is started like this, see if the same wave is started like this, then how do we write this initial phase? Initial phase is along negative y direction, right? Therefore, we can write it as, we have to write it as y is equal to a sine A sine kx minus omega t here minus phi. This is a initial phase minus phi here. So how do we write that equation again? In general, we can write that equation as y is equal to a sine kx minus omega t plus or minus phi. If phi is 0, then it means that wave is started from the origin. If phi is not 0, then we can say that wave is not started from the origin. Do you understand? Once observe that, I'll give you a second, just observe that. I think you have got a clarity about what is a wave and what is a pulse. Okay, now, if a wave is propagated along positive x direction, how to write this equation? If it is propagated along negative x direction, how to write that equation? X minus vt is what? X plus vt is what? Okay. Now see here, we are going to observe the change in phase. Suppose if the wave is propagating like this, if there is a change in phase at a certain distance x from the origin, at a certain distance x from the origin, okay, at a particular x distance. Now I have shown that in this diagram. Now while the wave is passing at t1, and I have taken it by continuous lines, and at t2 time, after t2 time, then I've taken it with dotted lines. Okay, now both are same only, but t1 is the initial wave and t2 is a wave after some time, means the propagation of wave after t2 minus t1 time. Okay, now we are going to find out what is the relation between change in phase as well as change in time, as well as time. Okay, we are going to see that relation now. At same distance x, at same distance initially, the wave was passing like this, and after some t2 time, the wave will be different. Am I right or not? So the phase is changed. Here you can observe the phase change in these two waves. Therefore, you can write first. Let us take that phi 1 means phi 1 means phase at time t1. Okay, phi 1. Now I'm going to write it as, see here, phi means phase. Okay, now that I'm going to write it as 2 pi into t1 by t minus x by lambda. Here x does not change. At the same x value we are calculating. Okay, x by lambda plus phi 1. Okay, it is phi 1, right? What is the initial phase? It is started initially from same phase, no, right? Therefore we can write phi only, same phase, initial phase is same. Now again, if we write phi 2 means after t2 time, we can write it as, the phase can be written as t2 by lambda, I'm sorry, t2 by capital T minus x by lambda into x by lambda plus phi. Same initial phase. Initial phase does not change, no. Means initial phase means what? The particle, or the phase of the particle at initial position before the wave is originating. Okay, now at the point where the wave is originating, that is initial phase, right? So now these are two phases at t1 time and at t2 time. Now, what is a change in phase? Here you can write that delta phi. Change in phase can be written as change in phase can be written as, we can write phi 2 minus phi 1. So therefore, phi minus phi, however it is cancelled, right? That's why we can write 2 pi into T2 by T, 2 pi into T2 by T minus x by lambda minus 2 pi into T1 by T minus x by lambda. Okay, phi 2 minus phi 1, change in phase we are calculating, right? Therefore, 2 pi into, however, minus x by lambda here, minus of minus you'll get plus x by lambda, 2 pi into x by lambda. So x by lambda gets cancelled. That's why we need not to write that, right? So 2 pi into T2 minus T1 by capital T. Here, how do we write this? 2 pi into delta T by 2 pi into delta T by. Do you understand? Okay. So what is a phase relation? What is the relation between the change in phase and the change in time here, time interval? We can write it as delta pi is equal to 2 pi by T into delta T into delta T. This is the relation between change in phase and change in time. This is the relation between change in phase and change in time. Okay. So let us see variation of phase. Variation of phase with a distance. How the phase changes with a distance. Okay. Here, let us consider two different positions from the origin, that is a position x1 and another position x2. Then what will be the distance from x1 to x2? We can write it as x2 minus x1, right? Delta x it is. Okay. Then what is a phase difference which is related to delta x? Okay. Then we can write first phi 1. First phase we are writing phi 1 means phase of the wave at a distance x1. Okay, at a distance x1, that is phi 1 we are writing. So that phi 1 can be written as 2 pi into T by capital T, small t by capital T plus, sorry, minus x1 by lambda plus phi. Initially we have seen how to write the phase, right? Then how to write phi 2 here? Phi 2 can be written as 2 pi into T by capital T, because at the same time we are calculating two different positions, the distance between two different positions. So at the same instant of time, at the same instant T, we are finding out the change in position delta x, right? T by capital T minus x2 by lambda, and initial phase, however, it does not change. Initially from where the particle is started, or from where the wave is started, that initial phase does not change, right? Therefore, delta phi, let us write what is the change in phase. Now let us write change in phase, delta phi is equal to phi 2 minus phi 1, which can be written as 2 pi into small t by capital T minus T2 by lambda minus 2 pi into small t by capital T minus T1 by lambda. T1 by lambda. Right? Now see here. T by, sorry, I'm sorry. I have written something different. I'm very sorry. So t by capital T minus x1 by lambda, and it is x2 by lambda. Now small t by capital T, small t by capital T, plus or minus, both gets cancelled, right? Therefore, we can write 2 pi into directly I'm writing minus x1 is here actually, and here minus of minus x2, it becomes plus x2, right? Therefore, can I write it as x2 minus x1? So that x2 minus x1 divided by lambda. So how do we write this relation? 2 pi by lambda into delta x. Okay. Therefore, how do we write that relation? Delta phi is equal to change in phase is equal to 2 pi by lambda into delta x. 2 pi by lambda into delta x. This is a relation between the change in phase and change in position of the particle in a wave motion, right? This is about why change in phase of particle in a wave motion, right?